Okay, I think it's recording now. Yep, it's recording. So now can you see the MATLAB window which is opened here?
Yes.
Yes.
Okay. So now what I can do is, yeah, so I have uploaded some of the problems. So if you can open that file in, then it will be easier for you to follow along. So for example, in that there was one problem. It was that, maybe I can also open it here. I can also open um, let me open it from yeah. So can you see this problem file?
Yes.
Okay, so it is asking that what is the output when the following commands are implemented. So for example, if I just copy and paste this command from here to MATLAB. So now can you see the MATLAB window? Yep. Okay, so what is going to happen? So for example, if you see that over here, I have a variable a, and then I have the square bracket, which shows that I am going to define the uh, some matrix, and then 1 colon 3. So this colon is a special operator. When this column is used, then it will mean that we will continue, we will increment this first value by one amount. So from 1 to 3 means, so the next value will be 2, and then after 2 the next value will be 3, but that 3 is the ending value over here. So 1, 2, 3 will produce the results 1, 2, and 3. Similarly, 2 to 2 to 6, this is another over here. And then one more thing, after 3 we can see a semicolon over here, a semicolon over here. So it's the semicolon shows the end of the row. Okay, so then the next element will start in the next row. Okay, so it will be, so it is now showing as 2 colon 2 column 2. So 2 colon 2 column 2 means here we are using 2 columns but with 3 numbers. So in the first case we were using the only 1 column. So when we are using with 1 column, so by default it will mean that the value will be increment by 1. But when we are using like 2 colon 6, so the value will increment by 2. So it will be 2, 4, and then 6. Okay. And the next is also a 3 element figure. So that this is the third row. So 3 minus 1 minus 1. So it will mean that the increment over here will be minus 1. So from 3 to minus 1 is 2, and then from 2 to minus 1 is 1. So now if I will enter it, the result I will obtain is there is some error, invalid text character. Okay, 3. Okay, maybe I am because I just copy and paste, so that's why it happened like this. So since when some error happen and when you want to recall that command, so on the keyboard you will press the up arrow key. So it will then take you back to the commands which you will enter. And now when when you go back to over here, and then you can just make the correction. So I will backspace, I will remove it. Instead, I will put the -1 over here. And now I will enter. So it will execute this command. So as you can see, as I expected, it is a 3 by 3 matrix, 1, 2, 3, 2, 4, 6, 3, 2, 1. Okay. So in this way, it is showing like this. Okay. Okay, so, and the next command is, if I want to take the transpose of this matrix, so then I will take A is equal to A, and then for the transpose, there is very simple way. You will just input the keyboard character apostrophe, okay, apostrophe, which is the single inverted comma, okay, single inverted comma, apostrophe, okay. So if I want to take the inverse of that matrix, so maybe I can save it in A, or I can save it in B, whatever maybe the way I want. So if I will save it in A, then the contents of A will be replaced by the transpose of the matrix. So let's do it. So now execute it. So then it is now the transpose of this matrix. So instead of 1, 2, 3, the first row is 1, 2, 3. So this is 1, 2, 3. Instead of 2, 4, 6, the second column is 2, 4, 6 over here. So third column, third row is 3, 2, 1. It was replaced by the third column 3, 2, 1. Okay, so let's see another command over here. So what does it mean? Colon, comma 3, and then this is here over here. So it is if I use this command over here, and then what do I what I am going to get it? Okay. So for example, over here now I am referring to A, and then you can see that I am using the parentheses, not the square brackets. Okay, not the square brackets. So if so, there is a difference. So for example, over here I am using the square brackets. Square brackets are used for representing the arrays, but here I'm using the parentheses. So the parentheses are represented over here to refer to the certain elements in the matrix. So here what I want is I want the first thing over here is this column operator over here, and then the second reference over here is the 3. So first reference is for the row, okay, and when I enter over here as this first reference over here as a column, so it will mean that it will take all the rows, okay. For example, instead of colon I put just 1, so then it will just say it will take the first row. But if I will put the colon over here, it will mean that it will take all the rows, and then it is the second element is 3. So 3 means third column. So that means we will take all the rows in the third column. So all the rows in the third column means 3, 2, 1. So if I will put enter, the result should be then 3, 2, 1. Okay, in this case. Okay, so
I'm sorry.
Yes.
I was late for 5 minutes. So what was the what does the operator for a dash mean?
Which one?
I mean,
A apostrophe?
Yeah, apostrophe.
Apostrophe. So this is the apostrophe. This is for the transpose.
Oh, okay.
Yeah, this is for the transpose. Okay, so okay, so maybe the next command which I'm going to show you over here is this. So here you can see that I am now saving it in another variable A, and then what is this? Here A is a matrix, okay, and this is the matrix is a so this element is for example, this is the first column of A. This is the first column of A. And this is the transpose of this 4, 5, 7. This is a row matrix and its transpose. So it will be a column. And then this is the second column of A. So let's see how it comes out. So it will be like this. So as I have said that it will be the first column of A. First column of A was 1, 2, 3. So it will be 1, 2, 3. And then the second one is 4, 5, 7, but transpose 4, 5, 7 apostrophe. So it is the transpose. And then it is the second column of A. So it is 2, 4, 6. So it is a 2, 4, 6 now. So in this way, you can get some different matrices.
So what if we want to invoke not the row itself, not the column?
Yeah, if you want to invoke the row. So for example, if I want to get row number 2 from A, so then I will put A, and then since I want to get the row number 2, so I will put 2, and because in this row I want all the columns, so therefore I will put this, and then that will be 2, 5, 4. So because the latest A matrix is A, so it is taking the row number 2 from here.
So double the operator for the
yeah. So the colon operator over here will show that it will represent all the columns over here. If the column operator I am putting in the first place, it will represent all the rows.
So it is only the column operator for the matrix when we are using it in this kind of syntaxes, yes?
Yes, yes.
Okay.
And also for any type of arrays, it can be used. Okay, so there are some other functions as well. For example, if I have a matrix A, if we have this matrix A, and then if you want to find its diagonal, so there is a function DAG diagonal function, okay? Diagonal. So it will return the elements in the diagonal of the matrix. So I can put as diagonal of A, and then put it in the parentheses. So diagonal of A. So if I want, so for example, if I want a matrix which are the diagonal elements of A, so I should get an answer of 1, 5, and 6. So diagonal of A, I enter it, and then I get a column matrix of 1, 5, and 6. Okay. Similarly, we can apply, put some other function. So for example, if I want to sum the elements of A, okay, if I want to sum the elements of A, if I want to add all elements of A to be added together, so I will put sum of A. So it will be 6, 16, and 12. Okay, 6. So what will be 6? So 6 will be here, 3 plus 2 plus 6, and then 4, then it will be 16, and then 12. So in this way we can get it. Okay, so yeah, so we can play around with these different functions in MATLAB. Okay, so let's go to the problem number 2. Yeah, so in this case, this is the problem. Okay. So maybe you can try it by yourself. So I leave it.
Okay.
I leave this problem number 2. So then I go to the problem. Yeah, anyone asking something?
No, nothing.
Yeah. Okay. So problem number 2 is very much similar to problem number 1. So let's go to the problem number 3. Okay. So it says that the command linspace AB n generates a row vector of equally n space points between A and B. Use colon notation to write an alternative online command to generate the same vector. So test your formation for A is equal to -3, B is equal to 5, N is equal to 6. Okay. So let's try this linspace command. So what is the linspace command is sometimes very useful. So I can clear all CLC. Okay, I clear the space and then I have the clean command window. So I want to use the linspace command, linspace. So that means linspace is from linear spacing. If I want to linspace, so for example, if I say linspace from 0 to 10, okay, so it will generate 100 numbers equally distributed from 0 to 10. Okay, so you can see that it will start from 0 to 10. There will be 100 different spaces. Okay, 0 to 10, because I did not specify the interval. Okay, so by default, linspace takes 100 equally spaced points. Okay, so if in case if I want for linspace from 1 to 10, I want 9 equally spaced numbers. Okay, from 1 to 10, 9 equally spaced. So how will it go? So from 1 to 10, maybe 11 equally 9. Okay, let's try 9. Okay, so I will get like this. So from 1 to 10, so 1, 2.125, 3.25, 4.375. If, for example, I want from 1 to 10, 10 equally spaced numbers, so then I will get 1, 2, 3, 4, 5, 6, right? So for this, for the test case, the data given is linspace from -3, okay, 5, and 6. So from -3 to 5, 6 equally spaced numbers. So then we will get like this: -3, -1.4, 0.2. So you can see that these numbers will be equally spaced. Okay. Another way to represent linspace is kind of also like this. We can use also the assignment statement as well. So for example, instead of inputting -3 over here, we define A is equal to -3, and then we can suppress its input. And then on the same line, we can say that B is equal to 5. We can suppress its output, and we can say that N is equal to 6, and then we can suppress its output. And now we use linspace, okay, A comma B comma N, and then close it and then enter it, and then we will get the same answer. Okay, we will get the same answer. So we can use either the colon operator or the linspace, but linspace is useful when, for example, linspace is easy to use when we want to equally distribute the numbers between the two limits. Or the colon operator is useful when we want to have a control on the on the interval between them. Okay, so for a column space, I think what we can use is we can use this command. So because these numbers start from -3 to 5, and A is equal to -3, so the starting number will be A, and then the colon, and then the ending number will be the last number minus the previous number divided by the divided by 1 less of the value of n. Okay, so for example, in this case, in this simple case, 1 to 10, so there are actually 9 spaces in between. 1, 2, 3, 4, 5, 6. So for example, then how I will get this interval? I will take 10 minus 1, 9, then divided by 10 minus 1, that is 9. So in this case, for the colon operator, I will put this formula: b minus a divided by n minus 1, and then the term will be ending at b. Okay, and then in this way we will get the same number. Is it clear?
So the operator of the column here, could you repeat the function of it?
Yeah, so
I
here
mean,
we have just compared these two things. So in the linspace, it is very easy. So if we have the first number and the last number, and then we want to equally space it, so it's very easy to doing by the linspace. But by the colon operator, we have to find the interval in between them by the calculation. So we can use it by the colon. So, but both
okay.
linspace and the colon operator in this case are producing the same results. But
So
linspace is easier to use.
if I will write as the second part that by not b minus a divided by n minus 1, but other interval, will it give me any feasible result, or it will just say me that there is an
Yeah, you have to divide by n minus 1, because you know that from 1 to 10 there are actually internal spaces are 9 actually. Okay, although it is from 1 to 10, the internal spaces are 9. But if it will be n, then I think the results will be different. Okay, so one of the application of the linspace is that, for example, if you want to plot, if you want to plot some function. Okay, so for example, the function is a sine curve. So I want to plot y is equal to sine of t. Okay, so where t I define as where I define t as a matrix. Okay, with the lin space. Okay, linspace from 0 to 2 times pi. Okay, I define this matrix. Okay, 0 to 2 pi, or maybe I can say 0 to, I say, like 6 pi. Okay, maybe we can take 6 cycles. So if I suppress its output, then I will get some number. Here in the workspace, we can see that I will get 1 by 100 double number. So it's a t linspace. Then our y function is sine of t. The y function is sine of t. So I will enter it. So it is value of sine of t. Now I can plot. Now I can plot x versus y. So x value is t, y value is t value, y value is y, that is the sine of t. And then without putting any other argument, I can just input it, and then I can get the plot of sine curve. Okay. Of course, later on we can play with this plot to look it more better. So, but in this case, what I wanted to illustrate was that, so linspace we can use to generate values. So in this case, this linspace has generated the values of t from 0 to 6 pi with I think 100 values were generated. And then I use this sine of t function to generate the y values, and then I plotted that function. Okay. Okay, next, let's try the next problem. Okay, so problem number 4. If force F is applied to compress a spring, its displacement x meter can often be modeled by the Hooke's law, F is equal to kx, where k is the spring constant and the potential energy stored in the spring can be computed as U is equal to half kx square. So 5 springs are tested and the following data is compiled. So the F is this, X is this. So use MATLAB to store F and X as vectors, and then compare vectors for the, and then compute the vectors for the spring constants and the potential energies. So use the max function to determine the maximum potential energy. So first of all, what we have to do is, because from the Hooke's law, we have the F and X, and then what we can do is we can create the matrix, we can use this data, F and X, and then we can store them in the form of the vectors. And then from these vectors, we can calculate the K. So K will be equal to F over X. So if we have F, then divide by X. So it will be F over X. And then we can also calculate the potential energy from this formula. And then we can get the maximum value. Okay. So it's a simple exercise, but we have to just input this data 14, 18, 8, 9, 13. So in this case, okay, clear all CLC. Okay. So let me put the data first. So the first data is force. Okay. So I say force F is equal to this, and I input this data as a matrix 14, 18, 8, 9, and 13. So these were the forces given 14, 18, 8, 9, and 13. So 14, 18, 8, 9, and 13. And the X values. So next I will input the X values. So I don't need to display this force vector. So I will put the this semicolon operator to suppress its results. So X is equal to, this is the displacement matrix. It is 0.013, 0.02, and 0.009, 0.01, and 0.012, and bracket close. Remember that when you input data for the matrices, you can either put a space or you can separate this data on the same rows by commas. Okay, if you put commas, then it will mean that you will be entering data on the same row. So in this case, we want to get the data for the single first row. So we will get like this. So from here, now our task is to find the spring constant. So the formula for the spring constant is equal to, F is equal to, K is equal to F divided by X. So F divided by X. Okay. However, but if I will put the formula like this, I will be making a mistake. So let me put, let's put this formula like this. So I will get a mistake, an error. Not exactly the error, but what I was expecting was, it was not like that, because what happened is that it has took only the first value over here and then divided by, but the other values were not divided. So this is not what I wanted. So therefore, I would like to make some correction. The correction is that in the MATLAB, I want the element by element division. So for element by element division, so for this, I will need to use dot and slash operator. Dots, not just slash operator. It will be dot and slash operator. So in this way, I will get the element by element division, and then I will get a data like this. So in this case, each element each values of k which I will be getting, that will be corresponding to these f and x values. So the value.
Sorry to interrupt. Basically, it means that we should divide by the scalars of this vector. Yeah.
Yes. So we are taking the element by element division. Yeah. So it will be like a scalar division. Okay, so the next is to calculate the energy. So energy, the formula for the energy was U is equal to half kx square. Okay, so similarly for energy, it is there. So which represent by U is equal to 1 divided by 2. So 1 divided by 2 is a scalar, so we don't have to use dot slash operator. For scalar, we can use simple mathematical operations. So half kx squares. So half times k times x square. Okay, but here now I think we need to make some. So here, because 1 by 2 is scalar, let me put it in the parentheses for clarification purpose. Otherwise, parentheses over here is not needed. So scalar can be multiplied by the vector by using the normal operator. So there is no need to put a dot asterisk over here. But here, k and x are both vectors. And then we are multiplying these vectors element by element, we are not taking the matrix multiplications. So therefore, we will put a dot over here. Okay, so to indicate that k vector k, so the matrix k is multiplying with matrix x element by element. And similarly for x, we are taking the square. So square will mean that we need to take the squares of the elements of x. So therefore, we will put dot hat and the power sign over here. So this will mean that we will take the squares of the elements of the matrix, not the matrix multiplied by the same matrix over here. Okay. So in this way, when I will execute it, so I will get the respective values of the energies, string energies, which is produced. Okay. Is it clear?
Excuse me, may I ask?
Yes.
Why didn't put the dot when we were finding k? So we put it only.
Say again, I didn't understand.
So the formula for k is f divided by x, and we put dot only after f, but not after x.
Yeah, because we are dividing by, we were dividing f by x. Okay. So any operation which is happening, it is in between f and x. So if we put any dot over here, then that dot will not make any difference. It will be so the operation is happening between f and x. So that means.
Sorry, Professor, may I ask a question? There is k is equal to f divided by x. So it means like the sum of f divided just by the sum of x in the first.
So you mean this line?
Yes.
Yeah, this line is obviously giving us error. This is not what actually I wanted. I wanted the each element, these elements to be separated by them. And but how this answer has obtained, I did not check it. So maybe you can verify how this number has come. But
Okay,
I did not check it, so I don't want to spend. Yeah. So because since I don't want it like this, so that's why I moved to the next section. Okay. Then yeah, and then I think one point was that. So what is the I use the max function to determine the maximum potential energy. So what is the maximum potential energy? So for example, from these 5 values, so what is the maximum value? So here it is easy, we can even see it visually. But if there are hundreds of values, so then this function will give us the answer. So for the maximum potential energy, I will use the max function, and then I will refer to the U as the variable for the potential energy, and then it will give you 0.18. So the maximum potential energy is 0.18 in this case. So, okay, so this was problem number 4. Problem number 5. Okay, so the log function operates in an identical fashion to the plot function, except that the logarithmic scales are used for both x and y axis. So use this function to plot the data and function as described below. Explain the results. So in this case, we are going to plot the data. Okay, so here are some of the wind tunnel data. So for example, velocity is this, and the force is this. So these data can be described by the following function: f is equal to this u power this. So use MATLAB to create a plot displaying both the data using the circular magenta symbols and the function using a black dash dot line. So plot the function for v is equal to 0 to 100 meters per second and label the plots axis. Okay, so we have to go through one by one. Okay, so let's see what are the data we need to plot. Okay, so we have to basically plot the data for the velocity against the force. Okay, velocity against the force. So as we can see that the data for the velocity is uniformly spaced. So what we can do is I can use the column operator with an increment of how much? 10 and up to the value of 80. So first of all, let me, okay, here all CLC. Okay, so take the velocity first. So I take V is equal to, velocity starts from 10 and with an increment of 10 and up to 80. Okay, so if I want to visualize it, so then I can see that this will be the data of the velocity that will be generated. Okay, the force was, not uniformly distributed. The force was like this: 25, 70, 380, 550, 610, and then, so let me input this force over here. So force is equal to, now the force I will put as a matrix. So I will put the square brackets. Here for the column operator, you don't need to put the square brackets over here. Okay, but if we are creating the data manually, then you will need to put the square brackets. So it will be, the force will be 25, 70, 380, 550, 610, 1220, 830, 1450. Yeah, so this is the data for the force. Okay, 25, 73, 80, 550, 610, 1220, and 830, 1450. So, so what I can do is I can plot the graph, plot V versus F. Okay, and you can enter it. So there is some error. Invalid expressions. So I made some mistake. Yeah, because I put the square bracket over here. So it is suggesting me the correction. So this correction seems fine. And then the command has operated. Since I have my figure is opened over here, so I can see that this is the data which has been plotted. However, in this case, we were not asked to plot plot it by the simple plot command. We were asked to plot it by the log command. Okay. Okay. So what I wanted is we wanted is we will I will plot so what I wanted is a log command. Okay, so and in this case we have this force vector as well. So this is the measured data, and then this is the predicted data. Okay, so maybe I can represent this force by the formula, as with some other variable. Okay, so force by the formula. Okay, so force by the formula F is equal to, the formula is 0.24 2741, 0.2741 times VF times the V. Okay, times V. So V is this one. Okay, and then so the formula was yeah, it was 0.2741 times U. Sorry, it looks like U, but it is actually V, the velocity, power 1. Okay, so velocity power 1.94982442. So it is velocity times and then the power 1.9842. Times the velocity 1.9842. So here you have dot over here, and then here we have the dot over here. Okay, so this will be the velocity by the sorry, this is the force by the formula. We need okay, yeah, here actually we don't need to put dot because this is the scalar, and then this is the matrix. Okay, scalar and the array, and then because and then for velocity we have to take the power of this. Okay, so I will execute it. So in this way, I will get these values. So so it will be 0.1 into 10 to the power 3. So it is actually 26.4. So actually it is 25. So these are the predicted force values. So now we can plot the log plot by the log. So when we take the plot, so for example, plot V versus F, so it will plot velocity against the force. But when we want to plot the plot on the logarithmic scale, so we can use the log command for the plotting. So log, what I want to plot is V and F, and V and F, and then what I can do is I can plot log as V versus F. Okay, so maybe I can see how it looks like. Okay, and okay, so for this will be the plot log VF.
I have a question.
Yes.
What do we want to represent both VF and VFF in one plot?
Yes, we can represent it. Yes. We can represent it. Okay. So let me show you how. So in this case, the log plot should be a straight line. I think there is some mistake which I have encountered over here. So log VF. So let me, I execute this command again, log VF. So, but this command is a little bit not the straight line. It was same as before. So I think first of all, maybe or maybe I can plot input this command. Okay. Okay, in this command. So this command is actually log VF, and then OM means it is the M for magenta color, O is the symbol for the dots, and the other plot is for the VF and EF as well. VF is the, we have, first of all, we have to calculate the VF as well. So VF is given by this. Okay. So first of all, VF. Okay. So VF is the velocity by the formula. Okay. So velocity by the formula, in this case, we will be using the log space. And then I will apply this formula again. Okay, and after that, I will apply the log. And then I will get this formula in this straight line.
What is the minus dot point k parameter that you gave to the second part of the log?
Yes. This okay. So in this log plot, these are some of the character strings. Okay. So this character string first, and then another one is this character string first. Okay. So here, this, okay, this dash, you are asking about this dash. So this dash dot means that it is representing the dashed dot line. So a line in a pattern of dash and dot, okay? And the K is the code word for the black color, okay? Similarly, M is for the magenta color, and O is for the circle markers. Okay, so now if you look at the figure, then you can see that the this black line is shown as the dot dash dot, and the circles are in the magenta colors. Okay, like that.
Oh, okay. So basically, this plot just shows the correlation between the actual values and the theoretical ones.
Yes. Yep. So yeah, in this case, the figure is being replaced in the is being shown in the separate window. So but you can also dock that window as here. So edit plot and insert legend, insert cobweb link. No, the window here, and then yeah, dock the figure. So here the window has been the figure has been docked over here. You can also put the labels. So for example, what is the X label and what is the Y label? So you can also put it. Control V. So now you can see that the X label is V and the Y label is F over here. It has been put over. Okay, so that is the one example. Next example is exactly what will be displayed after the following MATLAB commands are typed, so that you can see it very easily. So maybe I can skip it. So let's try another problem over here. This is problem number 6, and then now this is problem number 7. So the temperature dependence of chemical reactions can be computed with the Arrhenius equation. So this is something like a chemical engineering problem. Maybe the other problem is, yeah, that may be more interesting for you. This problem number 7 and problem number 8 are of similar character. Okay, so maybe I skip problem number 7 and then go to problem number 8. Okay. So figure below shows a uniform beam subjected to a linearly increasing distributed load as depicted in this figure. The deflection can be computed with this formula. Okay, deflection, this is the formula for the deflection. And where A is the modulus of elasticity, I is the moment of inertia, and apply this equation and calculus to generate MATLAB plots of the following quantities versus distance along the beam. Displacement, slope, movement, shear. Okay, well, actually this problem looks to be very complicated, but I want to show it as simple as possible. So later on in your, I think you may be taking the structural analysis course. So you may be coming across these kind of problems, okay? And for these kind of problems, you may be asked to plot the shear force and bending moment diagram, okay? Well, you can do it, but suppose that you solve this problem by calculus and find the formulas for this. Okay, so for example, the formula for the displacement is given. The formula for the slope is dy over dx. That means you have to take the derivative of this with respect to x, which is easy because it is a over here x. And for the moment, you will take the second derivative. For the shear, you will take the third derivative. For the loading, you will take the fourth derivative of this. So basically, you take just the derivative and then multiply by EI, and then you will get the results. Okay. Yeah. So I think solving the solution by the method of integration. Okay. Derivation and integration. Okay. So So how we can show the solutions, okay? So in this case, what we can do, it will be better to formulate this problem in the form of the script, okay? So let me close it over here and clear all and CLC. So for this we can, it is better because there will be many commands, although we can do it by on the commands as well, command side as well. But if you write a script for that, then it will be much easier. So for example, writing in the script, it is easier because a script can be easily edited as well. So for invoking the script, I can use the edit command, or maybe from this window over here, I can also start like from new and then script. So this for the script, first of all, I will define the properties of the material properties. So the material properties have been given as like this. So I will just copy and paste from my solution, okay? So the value of E, so here you can see that the value of E has been given like this, okay? And that means 50,000 into 10 to the power 3 into 10 to the power 8. And then the value of the moment of inertia has been given. And W naught was the uniformly distributed, varyingly, W naught was here. It was the this load, okay? W naught was also given in this problem, okay? And W naught is given, and L is equal to, the length is given 600 divided by 100. And then dx is equal to 10 divided by 100. So dx is the length is 600. So for example, what is length is given as here. Yeah, so here all the data has been given over here. Delta x is equal to 10 centimeter. So delta x have to be used where? So yeah, somewhere in here, delta x have to be used. So anyway, I think if I enter it line by line, it will take much longer time. Maybe I can just show you the result, okay? So it will be like this. So this is the total plot. Actually, it looks quite complicated, but actually it is not. So maybe I can explain to you a little bit. So for example, what is this x? So x is the value which changes from 0 in the interval in increments of L. That means we need to plot the values of x, and then we need to give some interval. So that's why we took an interval of 10 centimeter interval, okay? So from 0 to L. So this is the value. And then this is for the, okay, yeah, this is some command. And then this is the equation for the slope, okay? This is the equation for the slope, which is given to you. And then this is the equation for the angle, okay? That is the slope. I'm saying it wrong. So y is this equation for the deflection. Theta is the equation for the theta is for the slope. M is for the bending moment. V is for the shear force, and W is for the force. W is for the load. Okay. So here you will be seeing that we'll be using a term subplot. Okay, a subplot is basically the part the part of the plot. So that means the subplot command divides the plot command into various portions. So here the subplot is 5, 1, and 1. What is the meaning of these numbers? So 5 means we want actually 5 plots in this case. As you can see that we want to plot the displacement against x. That means how the displacement is changing with respect to the along the length of the beam. So the second is for the slope, the third is for the movement, the fourth is for the shear, and then the fifth is for the loading. So we need 5 plots. Okay, we need 5 plots, and so that's why 5 to 1 means the overall plot has been divided into 5 rows. So on the top there will be the plot for the displacement, then for the slope, and then so on. And 1 means there is no second column for the plot. And then the third number 1 shows that this is the first one, then this is the second one, then this is the third one. And in the second, after each subplot, we have the plot command. So it plots this plot command plots x versus y, and then it provides the grid, and it provides the y level value. Okay, for each plot. Okay, the second plot plots x versus theta, that is the slope. The third plot plots x versus movement, that is the movement. Bending moment, and then the fourth plot plots x versus velocity, shear force. Shear force is represented by V, and then the last one is for the loading, and then there is the label for the loading. Okay, so in this way, this script is created. So we need to, when you create the script, you need to save the script as well. So you can save the script as structure. Okay, structural problem. Okay, so save. So once you have saved it, then you can run this code. But here there is some error. Okay, there's some error. So, and you can see that the error is the attempt to execute script struct as a function. Okay, maybe I can just recopy my code. Okay. And then try to execute again. Okay. And then save, and now I try to run it. Oh, it is not running. So there is some error. So this is the problem in the programming language. So when we have some error, then it is some okay, so it says that there is some error. Okay, so attempt to execute the script struct as function struct.m, error in subplot line 602, subplot, so line 602, and it is axis units normalized position error in struct line 10, so subplot 511. Maybe there is some error over here. Okay, so, but anyway, if this this code would work, then you may be able to get these plots over here. Okay. When now there is no time for me to find the errors. It will take much longer to correct it. So the plots you will get like this. Okay. So first plot will be the shape of the deflection curve. The second plot will be the slope. The third plot will be the bending moment. The third plot is for the shear force, and the last plot will be for the force itself. Okay, so so this was some exercise for the MATLAB today. Yeah, so so I hope maybe I have tried to you have got some points for your other for the upcoming assignments for this course, and it may have been useful for you. Do you have any questions?
Yes. So where we can see or see full like description of the parameters that you used for the for making a script, because some of the parameters there, like the format and short G, like that one, are there like the directory such as in Wolfram Mathematica where you can see all the, which parameter does what?
Yeah, okay. Oh, let me share again. Mathematica. Mathematica, yeah. So, okay, let me close this and clear. CLC. Okay. So for for finding help for any command. So for example, you will type the command as help, and then if you want, for example, just we have used the word the command subplot. Okay. So you will put help subplot. So it will provide the help for sub plot. What is saying that? Okay. Maybe clear all. Okay. And now I put help subplot now. Okay. Anyway, if you want to take help for any function, so for example, help plot function.
I guess it because you opened the script.
Yeah, the script is causing some problem over here. Yeah, this script is causing some problem. So I opened it. Yes, so clear all CLC. Okay. Okay, help say lot. Okay. So this is maybe I can.
Yeah, I tried it. It works when you open the clean document.
Yes.
I guess it's problem with the when you add scripts.
Yeah.
It starts to invoke
something has
like
happened,
from the script.
Not working very well.
I guess it tries to open the some kind of variable or something from the script.
Yeah, maybe I can use some other window. Okay. Okay, so clear CLC help plot. Okay. Yeah, I think my MATLAB has run into some problem. But anyway, whenever you want to get some help from the MATLAB, you will put the help and then it will provide you some of the details. Yeah, anything else?
When will we have receive our first like laboratory work problem?
No, I want to cover some more tutorials on MATLAB, and then I will give maybe after this week.
Okay.
Yeah,
Thank
no, not after this week, because this is the week. Then I have one more, and then in the next week. Okay.
Okay.
Yep. Yes.